Pokoknya నిన్న ఎగ్జామ్ కి మిడ్ ఎగ్జామ్ కి తీసుకెళ్లారంట కదా పిల్లలు. ఎంతమంది వెళ్ళారు?
ముగ్గురు ఎందుకంటే ఫస్ట్ పీరియడ్ రాయలేదు.
హలో
Good evening, ma'am. Good evening. Am I audible?
Good evening, sir.
Yes, ma'am. This is Dinesh Reddy, paper number 154. Can I present it, or do I need to wait for a few more minutes?
There'll be a brief introduction.
Okay, sorry.
A few minutes.
Hello, Dipti ma'am.
Yes, sir.
Yeah, am I audible?
Yes, sir. Yes, sir. You are audible.
Okay.
Good morning, Vaibhav sir, Padmavati ma'am, and Abhishek Rawat sir.
Yes, ma'am.
Ma'am, can we start the session?
Yes.
Okay, ma'am. Thank you, ma'am. A very good afternoon to all of you. On behalf of Department of Computer Science and Engineering, NIT Raipur, and 4th International Conference on Machine Intelligence and just a minute, ma'am. Sorry. On behalf of Department of Computer Science and Engineering, NIT Raipur, and 4th International Conference on Machine Intelligence and Signal Processing, I, Deepti Sisodia, welcome all the respected session chairs and participants. Before we start the session, let me introduce our esteemed session chairs. Our first session chair is Dr. Vaibhav Soni. Dr. Vaibhav Soni is presently working as an assistant professor in the Department of Computer Science and Engineering at Maulana Azad National Institute of Technology, Bhopal, India. He previously worked as an assistant professor in the Department of Computer Science and Information Systems at Birla Institute of Technology and Science, that is BITS Pilani, India. Moreover, he was associated with Intel Technology India Private Limited. He received his PhD at Birla Institute of Technology, Mesra, India, under the supervision of Dr. Dhirish K. Malik. The main field of his research interest include ad hoc and wireless sensor networks, soft computing, and deep learning. He has contributed many research papers in international peer-reviewed journals and conference proceedings in the above mentioned areas. Our next session chair is Dr. N. Padmavati. Dr. N. Padmavati is currently working as a professor and head of Department of Electronics and Communication Engineering and Dean R&D at Vishnu Institute of Technology, Bhimavaram, Andhra Pradesh. She received her PhD from Indian Institute of Technology, Kharagpur, MTech in Digital Electronics and Communication, and BE in Electronics and Communication Engineering. Her research interest includes mobile ad hoc network, reliability modeling, mobile communication, underwater networks, and image processing. She has published papers in peer-referred journals. She is reviewed for reliability engineering and system safety elsewhere, IJQRM, International Journal of Wireless Personal Communications, Springer, SSR and elsewhere, International Journal of Engineering Research and Technology, many IEEE conferences, WCSET 2016, and session chair and invited speaker for Comet 2K19. She is a life member of ISTE, professional member of Society of Digital Information and Wireless Communications. She has authored a book in Lambert Academic Publishing and 4 book chapters published in Springer. She worked on a project titled Reliability Measures and Evaluation of Underwater Networks, sponsored by Government of India. Thereafter, we have Dr. Abhishek Rawat sir as our next session chair. Dr. Abhishek Rawat received his Bachelor of Engineering in Electronics and Communication Engineering in 2001, Masters of Technology in Microwave and MM in 2006, and PhD in Smart Antenna Arrays in 2012. He has worked as an assistant professor in the Electronics and Communication Engineering Department at Samrat Ashok Technological Institute, Vidisha, Madhya Pradesh, India. Currently, he is associated with Institute of Infrastructure Technology, Research and Management, that is IITRAM, Ahmedabad, Gujarat, India, as a department coordinator and assistant professor, Electrical and Computer Science Engineering Department. He received Young Scientist Award at 2007 by Madhya Pradesh Council of Science and Technology, Bhopal, MP. Dr. Rawat has published more than 70 articles in international journals, books, book chapters, national and international conference proceedings. He has 4 papers published and 1 granted Indian patent. He was also involved in the field trials of Indian Regional Navigation Satellite System, receiver of a Space Application Center, Indian Space Research Organization since 2016 to 2021. His research interests include satellite navigation systems, satellite communication, advanced communication system, antenna design, cognitive robotics, and peripheral security, drones, IoT, etc. Thank you, sir and ma'am, for joining this session. May I request all the session chairs and participants to switch on their video. In this session, we have 5 papers to be presented. May I request all the session chairs to start the session. Now I would like to invite our first paper presenter ID, Vivek Kumar,
Yes, ma'am.
to present his paper, a SAR ATR using a new convolutional neural network framework for the presentation. Please start, Vivek.
Ma'am, kindly enable screen sharing.
Sir, I have already enabled.
But I'm getting host disabled participant
No,
screen
sir,
sharing.
I've already made you co-host. Check it once again.
Yes, ma'am.
Deepti, am I audible?
Yes, ma'am.
When you will start sharing, I think then he would be able to.
No, ma'am, he has started sharing. Actually, I have made it already. I have already made it.
Okay,
Ma'am,
okay.
Ma'am,
Okay.
it's visible now.
Yes, yes, it's visible.
So good afternoon to everyone. Today I'm going to share my research article, that is SAR ATR using a new convolution neural network framework. So I will cover up following following topic: background, challenges in SAR image classification of SAR imagery, proposed convolution neural network, result analysis, conclusion, and future work. So
Mr. Vivek, sorry for disturbing. Can you put it in the slideshow mode?
just a second. Now it's visible proper.
It's fine, okay.
Okay, so before starting, I want to discuss some introduction about SAR images. So images is a visual representation of an object. So airborne SAR system developed in 1950s after World War II work on microwave band by using reflected signals from any targeted area under any weather situation. SAR is used to capture images by an active sensor that detects reflected responses from object as shown in the figure 1. The importance of SAR imagery in the field of geology, oceanography, disaster management, land observation, agriculture, and military operations makes them so popular. And the main challenges with the SAR images is, first one is resolution, high resolution of the images. It is around 7 meter to 1,000 kilometer. So it depends on the height of the capturing device. So it is affected by multiplicative noise, that is also known as speckle noise. So just because of the speckle noise, it is very difficult to analyze these kind of images. So I've gone through some research paper. So Sun et al. Proposed an adaptive boosting approach used with RBF function, in which the multi-class problem decomposed in bunch of binary ones with the help of error checking output code. Jai et al. Proposed template-based SAR ATR technique, in which the author generates SAR image template of targets from multiple angles using the generative depth neural network by using Bayesian network to construct a generative adversarial model network. Lee et al. Proposed a wavelet and spatial domain-based image enhancement algorithm used histogram equalization before SAR ATR process. Sivrajani et al. Proposed a multi-objective part swarm optimization approaching as a pre-processing step to remove speckle noise before pass it to the neural network. So to improve the accuracy of the SAR ATR, myself, I also work on the such kind of multi-objective speckle noise removal algorithm, that is multi-objective enhanced fruit fly optimization algorithm to remove speckle from the SAR imagery to achieve high accuracy. So problem description, I will complete this PPT in 3 sections. First one, in pre-processing part, I will remove speckle noise from the SAR imagery to achieve better classification performance. Development of the CNN, which can reduce the considerate number of execution time and training time, and then comparing the performance of the proposed technique with other existing state of arts. So image pre-processing step. In image processing pre-processing step, we have used dual tree complex wavelet transform to denoise our image. It is based on the bivariate shrinkage, in which we have applied fruit fly optimization algorithm to enhance its variance. So an enhanced fruit fly optimization approach has been applied to find the optimal fitness function value in the form of peak signal to noise ratio and mean structured similarity index. The overall average of all the data set which I have used in this achieved 34.89 dB PSNR value and 0.89 MSSIM value. So in this pre-processing step, we have used bivariate shrinkage method to remove speckle noise presence in the imagery, and then after we have applied adaptive thresholding to smoothing our data set. And then after we have applied fruit fly optimization algorithm used to means enhance searchability and convergence speed that is affected due to the fly distance range. So to improve global searchability, we need to use enough fly distance range. A booster function is used to improve global searchability. So in this fruit fly optimization algorithm, we have used a booster function that will help to optimize our fitness function, which we have used in the method that is PSNR and MSSIM. It is in the early stage, the iteration we have applied a heavy booster to get a large enough flight distance range. In the later stage, we have reduced this booster value to get a small flight distance range. So this is booster function BS equal to 1 minus root S minus 1 S max, where S is the current iteration and S max represents the total iteration count. Then comes to the convolution neural network, which we have designed. That is, in this neural network, each convolution layer consists of two-dimensional same size kernel, that is 5 by 5. Stat components 1 by 1 are used in a CNN model to compress the images. Padding parameters are also used to control boundaries and output effect in CNN. Due to fast learning capability, ReLU is used. Max pooling is being used to convolve input in finding the sharpest features and improve computational cost. Max pooling will also help in minimizing the scale, rotation, and shift variance. The flattening layer is being used to flatten the output of the convolution and pooling layer, which is further used as input for classification by fully connected layers. In this method, we have tested a dataset that is MSTR, moving and stationary dataset that is provided by the Sandila National Laboratory with DARPA, Defense Advanced Research Project Agency. In this work, we have used images of which has been captured on 17-degree depression angle, and then after we have used testing images which have captured on the 15-degree depression angles. So this is total number of targets in the data set. So there are 10 classes we have used in this data set: BTR60, T72, 2S1, D7, GIL, 131, BTR70, T62, BRDM2, BMP2, ZSU 234. So these are the images. In the figure, you can see that images which are affected by the speckle noise, and corresponding images are shown in the figure is optical images. Performance of the proposed CNN calculated on the basis of accuracy and loss. The proposed approach has resulted in a training accuracy of 99.67 and validation accuracy of 98.99%. After execution of 100 epoch, the following accuracy versus epoch graph and loss versus epoch graphs has been shown in this figure. So, conclusion: the key features of the proposed techniques are despeckle and augmentation in the pre-processing phases, and the proposal of a new CNN architecture. The SAR images used in this work are affected by multiplicative noise, which resulted in low accuracy score in object classification. Thus, despeckling and data augmentation has improved the proposed CNN model accuracy significantly. The experimental results show that the proposed SAR automatic target recognition techniques has outperformed existing state-of-art technique. The proposed approach has resulting in the training accuracy of 99.67 and validation accuracy of 98.98. In the future, large data set consisting of more objects can be used for generalization, and the same pre-processing step may be applied with the ensemble learning method. So these are references I have used in this work. So if you any queries, then
Mr. Bebe,
yes, ma'am.
can you move on to your slides where you made use of the optimizer, your block diagram?
This one.
Yeah.
Yes, ma'am.
Threshold optimizer, you are saying, no? What type of optimizer have you used here?
Ma'am, actually, we have used fruit fly optimization approach with the booster function. So this is means basically my previous work in which means we have published it. So we have used fruit fly optimization approach in which we are
Can
improving
you justify with that why fruit fly optimization?
Ma'am, actually, fruit fly optimization we use
Can you
just because.
be a bit louder?
Ma'am, we have used fruit fly optimization just because of its searching ability. So it is means it is taking less time than compared to the PSO. So that's why we have used to reduce the time in the despackling part.
Have you checked the computational time? You're saying it takes lesser time.
Yes, ma'am. We have
Work on that.
yes, ma'am. Actually, we have used a previous research paper that is just second, ma'am. Yes, ma'am. Sivrajani and et al. Proposed a multi-objective part swarm optimization. So we have used fruit fly optimization instead of part swarm optimization approach in this work. So we have compared our execution time with this paper as well.
So what is your sample data size?
Ma'am, sample data set we have used in the training phase as 36 images, and in the testing phase we have used 36 images.
Are you training your image?
Yes,
Are you
ma'am.
training the data set?
Yes, ma'am.
Yeah. So can you tell what is the learning rate you have
0.01.
used here? Yes?
0.01.
0.01.
Yes, ma'am.
So you are satisfied with that?
Yes, ma'am.
So, performance metrics are PSNR and MSSIM. That's all. Only these two you are looking into?
These two are the parameter on which we have means pre-processed our data set mean to remove speckle noise and then smoothing all the images used in this data set. And then after we have used our convolution neural network, this one. So we can say that in the phase of
Have you
despackling.
taken your data?
Sorry, ma'am.
From where have you taken the data sets?
Ma'am, this data set is freely available on the website.
From? Sorry, I couldn't get you.
Ma'am, this data set is freely available on the website of US Defense.
Okay.
My question is one question I just want to be added over here.
Yes, sir.
Particular images of this particular data set belongs to?
Which particular
Because you have
image?
told it's the star images.
Yes,
Okay?
sir. Yes, sir.
And what are the distance and which particular satellite you have taken this particular images? This description is also very important.
Okay. Yes, sir. Distance. Sir, I know that these images are captured with the X-band frequency, but I don't remember the exact distance of the object from where these images are captured.
You are getting from the satellite? These are satellite images?
Yeah, these are satellite images.
Okay, because in the SAR images, if you are taking from the satellite for the particular object, they are a bit very clear. I don't know why you are going for all this particular type of. What is your motto of doing so?
Sir, these images are not clear as we can see that in this figure you can see that this is the optical images of a vehicle and this is the corresponding SAR images. So we have used we have cropped these objective from the images. So
Okay.
optical images is much clearer than the SAR images. So it is very difficult to recognize the class of the SAR.
Then why we have to go for the SAR images?
Sir, there are means to find out, sir. Nowadays, we all know that about the S-400 missile system purchased by India from Russian government. So that is basically work on the SAR images to means detect the particular military object to means hit these object. So on the basis of classification only we can hit these military
SAR
vehicles.
images, okay, I think you just remember this thing. SAR images have even very
Sir,
clear.
one,
in
one,
presence
sir,
of-
sir, SAR images are popular just because we can capture these kind of images in any weather. Even in the foggy area also, we can capture these images.
Of course, yeah, this is the
Yes,
this
sir.
is the reason. And in
Yes, sir.
Indian satellites, I think we have a very nice scientist, Tapan Mishra. Tapan Mishra is also designed our own SAR, Indian SAR.
Yes, sir.
So these type of images you can also calculate in Indian environment. Okay.
I think these images are not available, freely available.
You connect with the SAC ISRO, you will got it.
Okay, sir. Thank you, sir. Thank you for information.
Okay, sir, can we move on to the next presentation?
Yes, ma'am. Please.
Yeah. The second presentation can,
It's a request to all the participants to please be fast because we have shortage of time. So you are having only 6 to 7 minutes of presentation. Any other query from session chairs?
Yes, ma'am. I wanted to ask one question.
Yes, sir. You
Hello.
can.
Actually, what are the other models you consider for comparison purpose? Vivek? Hello.
Vivek, are you there?
It's Vivek, right?
probably he has left.
Okay,
Yes,
you already. Okay, that's okay, ma'am. Okay.
Okay, sir. I would like to, it's a request to all the participants to please don't leave the session because at the last we will have to take a group photo. So please, participants, do not leave the session. I would like to request another participant, Mr. B. Dinesh Reddy, paper ID 154, titled as Deep Neural Network, Deep Neural Transfer Network Technique for Lung Cancer Detection. Please.
Yes, am I audible? Yeah, I'm audible.
Yes, you can go ahead.
Yeah. So good evening, one and all.
Dinesh,
Yes, ma'am.
please put it in the slideshow.
Yes, ma'am. Done, ma'am. So my topic research area is network transfer technique for lung cancer detection. So these are the table of contents. First, I'll talk about a background. Next, I'll talk about literature survey. And next one is a problem description. Next one is methodology. And next one is results and discussions, conclusions, and references. Ma'am, coming to the lung nodule detection is a critical in improving mortality of the patients with lung cancer. Right now, coming to the lung cancer detection or a classification, the popular input images we usually take is in a CT scan images. All the CT scan right now, my work, the input images I have taken from a LUNA 16 data set. It is an open competition that is in a benchmark data set. There we have collected.
Hello.
Yes, sir.
Okay.
From there, we have collected all the input images and we have conducted an experiment on the. Yes, ma'am.
Yeah, can you please be a bit louder?
Yes, ma'am. Someone is talking.
Yeah, please be a little bit louder. Your voice is not audible.
Yes, ma'am. So I have worked on the LUNA 16 data set and all the images in the LUNA 16 images are the annotated images. So all the images are annotated by the 4 radiologists. So we have worked on those images and it is in a benchmark data set and it is openly available on the internet sources. So coming to the literature survey, I'll discuss about each and everyone in a detailed manner.
Dinesh,
Yes, ma'am.
your slides are not moving.
No.
Present
Is it moving?
once again?
Yes, ma'am. Sure. Ma'am, is it visible?
Yeah, it is visible now.
Yeah, let me discuss about a literature survey. So most of the literature survey, coming to the lung cancer classification, most of the lung cancer classifications proposed by the various authors have not been implemented by any of the radiologists because out of the trustworthy matters are more.
Sorry for interrupting, Dinesh. Again, the slides are not switching from one to another. We are able to see only the first slide, that title slide only.
I think there is some.
Yes. Now it starts moving.
let me, I'll share my screen again, ma'am.
Yes,
I
yes.
think due to some technical problem, I can. Let me share. Ma'am, is it visible now? My slide is on literature
Yes,
survey.
yes, yes. Now it is showing the literature survey slide.
Yeah. So I have picked up by meta-analysis. I have picked up the major 4 most important researchers' work. So if we observe the first research gap I have identified here is most of the work done on lung cancer classification are not trustworthy. That means most of the radiologists are not practically using those work. And second research gap I have identified is the accuracy rate of lung cancer classification is very minimal. And third one is the data to work on a lung cancer classification are very minimal. That is the third research gap. And coming to the fourth research gap, what I have found is usually radiologists observe the CT scans in a 3D perspective. So all the research work which are happening in the recent past are doing are not up to the mark, and it was not trustworthy. So these are the most important 4 research gaps I have identified in my work. So coming to the problem description, what we have done is I have taken a LONA 16, and we have achieved a promising accuracy of 96.86% and precision of 91.10 and sensitivity of 90.78, specificity of 98.13 with an AUC of 99.37. We achieved this map. And for this work, we have used a convolutional neural network because CNN is the best for image classification problems. So we have picked up the CNN. When we have done on a literature work, we have found out that the CNN is the best model. That is why, first of all, we have fixed it to CNN and we have proceeded with our work. These are the problem descriptions. First one is spotting the tumor is in a difficulty part. So most of we have to spot the tumor. And second is after finding the tumor, we have to differentiate whether it is in a group of pixels or it is in a tumor. That is a difficult time. We have to find it out. And coming to this is the methodology we have used. So we have taken an input image from a LONA 16. We have used a convolution, and next one is a polling layer. Next one is a dropout layer, and next one is in a softmax and classification. We are identifying whether it is in a benign or a malignant. So these are the basic architecture, overall architecture we have used. And this is the results of my research work, ma'am. These are the research work. We have compared our results work with other researchers, and our proposed net validation accuracy is 100 and testing accuracy is 99.03, and validation accuracy 100 and the testing accuracy is 99 point. And LIDC is in a repository which is similar to a LONA 16. 1006 images we have taken, and training and testing is 90 and 10%, and we have compared with that with an author Zing et al. And method is used here is a convolutional neural network, and these are the various results we have acquired when we compared. So conclusion, in this paper, the researchers have proposed a deep neural network based on Google Net with a maximum dropout ratio of the reducing the promising time. This network reduces the overfitting at the time of learning by using the dropout layer. Excuse me. And the proposed method, 60% of neurons are fully connected layer, which is a higher dropout than the existing Google network. Experiments were conducted using the pre-trained CNN architectures such as AlexNet, GoogleNet, and ResNet. Here we have taken a transfer learning on a LIDC pre-processing dataset. So among the 3 pre-trained architecture, ResNet produced the highest accuracy. The proposed net achieved the highest accuracy than the pre-trained architectures and the state-of-the-art methods. So these are the conclusion we have drawn from our work. So these are the references we have taken. And thank you. Any questions, ma'am? Any questions or suggestions, please?
Can you please go to the what result section? Actually, the slides were not changing at all.
Sorry, sir. I mean,
No, that's fine. Can you go to the slide result discussion? Okay, fine.
Is it fine, sir?
Okay, that's fine.
Yeah. Thank you, sir.
Oh, so what exactly have you proposed? Which particular model have you considered?
Sorry, sir. I'm not.
Because these are some these are some base architecture, not any deep learning model.
Yeah, sir. This is the starting point. I have started my research, and that's why I have taken a benchmark data set of LONA 16. I have been to a local hospital here in Visakhapatnam, and I
No,
have
that's fine. You need to be very specific, right, with your answer. We don't have that much of time.
okay, sir.
See, just since you just started working on this area and you're getting 99% of accuracy, how
Sir.
come? Even without using any known deep learning models.
Yes, sir. Coming to the Luna 16 dataset, it is in a benchmark dataset, sir. All the images are annotated, and if we've been to the Luna 16 experimentation result set, since it is an annotated and it is in a everything is fixed. So because of a training within a we have achieved a 99.03% accuracy, sir, on testing.
Okay. Okay.
Sir, any questions?
Can you go to your block diagram?
Yeah. We have pruned the layers, ma'am, neurons. That's why we have used a dropout layer here. Two types of a drop, sparse and
The
dense.
slides are not still in results and discussions only.
Sorry. Let, ma'am, is it visible now?
Yeah.
Yeah. Ma'am, we have used a dropout layer here instead of sparse.
Okay. Any more questions, other members?
No question from my side.
Abhishek, sir? We'll move on with the next presentation.
No question from my side, ma'am.
Okay. Vaibhav, sir?
Ma'am, I already asked the question.
Okay. Okay, then we'll move on to the next presentation.
Okay, I would like to call Mr. Anurag Srivastav, paper ID
Yes.
315, titled as a deep learning model based on CNN using Keras and TensorFlow to determine real-time melting point of chemical substance. It's a humble request to all the participants to please don't leave the session till the end.
My slide is visible. Hello. Hello, am I
Yes,
audible? Am I
yes,
audible?
Yes, you can
Yes.
go ahead.
Very good afternoon to all respected members. Today I am here to present my research work. My research topic is a deep learning model based on CNN using Keras and TensorFlow to determine real-time melting point of chemical substances. I am Anurag Srivastav. My affiliation is DITU, Dehradun. So these are the topics which I am going to discuss: abstract, introduction, dataset, literature review, problem description, methodology, result and discussion, conclusion, and references. So the few points I have taken from abstract, and which is the deep learning is a subset of machine learning that uses artificial neural networks inspired by human cognitive systems. In many applications, deep learning becomes most successful approach where machine learning has been successful at certain rates. The proposed deep learning model is suitable for melting point detection apparatus, which determine the melting point of chemical substances. This apparatus generally used in pharmaceutical and chemical industries. The proposed deep learning model classify images of chemical states by deep learning network. It consists of TensorFlow framework libraries like Keras and activation function like ReLU, Sigmoid, MaxPool, and Flatten to determine melting point of chemical substances. The result is discussed in terms of image classification accuracy in percentage. The images from 2-class level gets maximum accuracy is 99.72. and maximum validation accuracy is 99.37, same as liquids image, and average value of accuracy is 84.17% or higher after the certain epochs. So introduction, melting point apparatus is a scientific instrument used for determination of melting point of chemical substances for identify purity of chemical substances. The detection of melting point is a tedious process in which user has to keep watching on capillary tube until unless chemical in powdery form converted into liquid form. Currently, various types of automatic melting point detection apparatus is being sold. Types of melting devices like Thelate tube, Fisher-Jones apparatus, gallon cam, melting point apparatus, automatic melting point apparatus, and digitally melting point apparatus. So this is a picture of different type of melting point apparatus which is being sold in the market. So digital melting point apparatus use computer vision techniques. It does not require user attention and determines melting point automatically. Earlier process of image classification was totally based on machine learning, but it accuracy and classification process have some limitation. So in this paper, a deep learning model, which is based on DL model.
Aruna,
Yes,
sorry
sir?
for interrupting you, but instead of reading the slide, can you please explain in your own language and try to be a bit brief about it?
Okay. Okay, so
you don't need to read the entire slide. Okay.
Okay, sir. Okay. So actually, in this paper, I have used the deep learning model for determining the melting point of chemical substances. So this model can be deployed on various platforms such as a desktop, laptop, or single board computer also. So in my research work, I have used the data set. I have created my own data set. Image data set consists of images of capillary filled with chemical substances from real-time video processing during melting point determination. So it contains the 2,500 images, in which 1,322 belongs to solid state, and while 1,178 images from the liquid states. So these are the literature survey. So I have read the 10 papers, and now the next is the problem description. So the intention of this proposed work is to make fully automated melting point apparatus, which does not require the human interference. It determines melting point of chemical substances using proposed deep learning model by classifying image of DCS image dataset. So this is a methodology which I have used in my proposed work. I have created an experimental setup. In experimental setup, I have used the capillary aluminum heater block, cartridge heater, proposed DL model, temperature sensor, and single board computer. These are the hardware which I have used, like aluminum heater, cartridge heater, capillary tube. And in this software part, I use the my DL model. So the proposed DL model implemented in Python, and it classify images into categories, either chemical in liquid form or in solid form. So when my proposed DL model gets the capillary image in liquid form, at that moment, the current temperature will be treated as a melting point of that chemical. So this is a proposed framework for determining the chemical melting point detection. Here you can see this is a capillary tube and camera and real-time video processing. And this is my proposed DL model. And when my DL model gets the images in liquid form, then that time the temperature will be represented as a melting point of particular chemical substances. We once defined the image dataset for training and validation purpose. The NDL model neural network with maxpool and ReLU activation function. I have used the maxpool and ReLU activation function with my model. Its layer sequentially fitted in listing manner.
Sorry for interrupting, Anurag. Please fasten the presentation.
Yes,
we have very short of time.
Yes, I have used the convolution 2D flatten and dense layer, also used in proposed DL model. And in the first layer, I have used the 16 filters, which having size of 3, and 32 filters, which having also size of 3,3. And in the second layer, I have also used the 64 filters. So now the results for testing purpose, we have evaluated the accuracy with and without activation function. I have used the my DL model with and without using the activation function like ReLU and Sigmod on different epochs of 15, 20, and 25. Total 6 cases I have used in my proposed work. 3 cases, in 3 cases I have used the activation function on the 15, 20, and 25 epochs, and the rest 3 cases I without using activation function. So finally, it shows increasing number of epochs with activation function obtained the max accuracy 99.72, and model validation max accuracy is 99.37% on DCSS MISP dataset. So this is a graph plotting for proposed DL model accuracy with activation function of 50, 20, 25 epochs. In the second figure, here we can see the model accuracy without activation function of 15, 20, and 25 epochs. This is my result. I have used the 15, 20, and 25 epochs with activation function and without activation function. So this is a max accuracy, and in the next column here we can see the max validation accuracy are shown here. So max accuracy is 99.72 and max validation accuracy is 99.37. And conclusion is the TensorFlow the proposed model has used with and without using activation function during experiment. So computed result with and without using activation function on different iterations, and found that activation function played a major role for getting high accurate results. So it's shown the 99.72 accuracy at 25 epochs with activation function, and without activation function is 77.78. So these are the references. Thank you. Any question?
Can you tell me why max relu and why leaky relu and why max pooling?
So these are the activation function which I have used. Actually, it predict more accurate results, sir.
Do any logical reason behind it?
Sir, activation function we use for activation.
No, any reason of using that particular max pooling? Why not average pooling?
Sir, actually, I have taken this concept from my previous work, sir.
Okay. So, did you consider any other models also?
Yes, sir. I can use. Sir, I didn't compare here, sir. Actually, sir, this actually no one has applied this model on the melting point detection. So I have done this unique, sir. No one had used it.
Still, you could use some other model in order to show like which particular model is working better, right? For the same type of data set.
Yes.
Okay.
I can.
Not just one model. Okay.
Okay, sir. Okay.
So I'm Dr. Padmavati. Okay. So you said your project is, your work is based on detection of melting point, right?
Yes, ma'am. Yes.
Using deep learning algorithms.
Yes, sir.
Yeah. So melting point of any specific metal?
No, ma'am. Actually, I'm going to determine the melting point of chemical substances which is in powdery form. I have taken the chemical which is in powdery form like glucose, and inserted the glucose in capillary and kept over the heater. Yes.
Okay. So are you showing your output in terms of melting points that it is detecting?
Yes, ma'am. As soon as I get the images.
Yeah, results I couldn't find that. That is the reason I'm asking. Or somewhere I missed it. I don't understand.
Actually, ma'am, I have mentioned in my research paper when my model gets the image in liquid form, that time the temperature which is currently increasing will be saved in particular variable.
Can you show those results if you have here?
Sorry, ma'am. Sorry.
Can you show those results if you have here?
Research?
Results.
Yes, ma'am. Yes, ma'am. Yeah. Ma'am, actually, here I'm showing the model accuracy, ma'am.
So, yeah, you're showing the model accuracy. You're done it with terms of activation function. If you have activation function, what is the accuracy? And if you don't have activation function, you showed that.
Yes,
and you also said that your activation function has got a major role in
yes,
in defining your accuracy, right?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Accuracy, you mean to say that it's giving the exact values of melting points?
Yes, ma'am. Yes, ma'am.
Yeah.
Yes, ma'am. Accuracy means key was successfully classified. Exactly, ma'am.
So do you have the theoretical values? How do you validate your results?
Ma'am, actually, I have put the actual images in validation data set. So, ma'am, so it is validating from the validation data set.
Without a proper approach, I don't think we can
Ma'am,
validate the outcomes.
Ma'am, actually, I have captured the images when my chemical converted into the liquid. So I capture that images and kept into the validate data set, and my model comparing with that data set and predicting this accuracy, ma'am.
Okay. Any other questions?
My side.
Okay. Okay. Thank you.
Okay.
Anurag.
Thank you. Thank you, ma'am. Okay. Okay.
Now I would like to call Mr. Dinesh Kumar, paper ID 370, to present his paper titled as AI-based real-time object measurement using YOLO V5 algorithm. Please fasten the presentation, Ganesh, because we have very short of time now.
Whether my screen is visible, ma'am?
Yes.
I myself, good afternoon to all. I myself, Ganesh Kumar, and
myself, Soundarajan.
We are going to present on the topic AI-based real-time object measurement using YOLO V5 algorithm. We are from the Department of ECE, Sona College of Technology, Siena. Next, these are the contents: background and literature survey, problem description, methodology, results and discussion, and conclusion, finally references. First of all, background. Basically, the main aim of the object detection is to detect all the instances of the objects from a known class, such as people, cars, or faces or objects in an image. And this object detection will be moreover like face detection. It will accurately detect the object from an image, and it will determine the size with and height from an image, and finally the object will be generated. Then these are the literature survey we have taken, and the first one is image based distance and area measuring system. This sorry ma'am. Its advantages are a CCD camera which will produce two parallel rays that will project two bright spots on the object, and that object will be identified finally. It has a major disadvantage that it will count the external clock pulse of the horizontal scan lines covering the area of the object. And the second one is the distance measurement system for autonomous vehicle using stereo camera. This advantages was object measurement using stereo vision will be better when compared to the object detection using a single camera. Then the third one is functional size measurement method for object-oriented conceptual schemas. Its major advantages was object-oriented method function points, which is a new FSM method for object-oriented system based on the conceptual schemas. And the fourth one is an embedded real-time object detection and measurement of its size. And the main advantages of the use of Raspberry Pi 3 and Raspberry Pi camera. And the problem description is the system will be able to measure the dimension by using an image from the dataset or camera using YOLO V5 algorithm for fast and better accuracy. And then measuring the dimension of an object through scale or any measurable devices could be done by could be also done by manual process, but it can consume time. So by reducing the manual process, we had automated and captured. Finally, the output will be generated. Then the final output will be In terms of Gaussian filters, then the final output will be filtered and the output will be generated. Next slide will be continued by Soundarajan.
Methodology. In first step, we know the dimensions for height and width by using formula. Then filtering the shadows and the output will be generated. So these are the steps. First of all, finding requirements, then width calculation, height calculation, filtering shadows and backgrounds, then the output will be generated. To determine the width of object formula is x equal to y into k plus z. Then the height of object formula is estimated height equal to height from camera plus k into tan into d. Next is we remove noise from image and then we filtering the shadow of image. In filtering the shadow of image, we use CAE lab color. It reduces the shadow. Without CAE, without filtering the shadows, we must find the object measurement, but it could be difficult. Finally, wherever the area will be in the in with color, that particular area object will be measured. So result and discussion in YOLO V1 algorithm, it couldn't find small object. In V2, network is able to detect and classify object. In V3, higher map values and faster or convolutional neural network algorithms. In YOLO V4, it has higher accuracy. In V5, it has higher accuracy and faster responses. So that's why we are using YOLO V5. In left side, these are normal image we taken, and then right side, the image with we remove noise from image and then filtering the shadows. That is, so why we are using YOLO V5 algorithm is better accuracy and faster response. For we take two image, one is with object and another one is without object. So both of them we can find the measuring. So we can find the height and width. Nice. Excellent. So these are our references. Thank you.
Any questions?
Okay, can you go to the result section?
Yes, sir.
Any other way to evaluate the performance, like accuracy, one score, precision score, anything?
Yes, sir. We have formulated in the inches, sir. We can also derivate the formula in
Have you or
centimeter.
not? Have you or not?
What, sir?
Have you used any performance metrics to evaluate the performance?
No, sir.
So how will you be able to check like whether your model is working correctly or not?
By measuring through scale or dimensions, sir.
How can I say that? There are always performance metrics to evaluate the performance of any model.
We have modulated, but it shows 89.
Are you getting the question or not? Are you getting the question or not? You must have read some papers where they have considered some performance metrics.
Yes, sir. Accuracy in sense.
So you should have used the same way.
Yes, sir. Accuracy, yes, sir. Accuracy, we have 89.45%, sir. Since
for object what detection, right?
Yes, sir. Object size detection.
And what about other models?
Other models, it shows 80%, sir. 88.
Did you run the model or not?
Yes,
you
sir.
Just saying it.
Yes, sir. I have run the model, sir.
Have you mentioned those accuracies, or have you mentioned the accuracies of those models on your paper, in your paper?
Yes, sir. I have mentioned that CAE lab color model and.
Okay, so the same thing have been mentioned in your slide also.
Okay, sir. Okay, sir.
So whatever results you're getting, it should be mentioned in your presentation also.
Okay, sir.
Any other slide for the same results or discussion?
No, sir. This comparison for both 5 YOLO.
So you ran all versions of YOLO?
No, sir. We have computed only for YOLO V5, sir. No.
V5 only, right?
Yes,
You
sir.
didn't try to run YOLO V4 for the same data set?
No, sir. We have tried, sir. YOLO V5 we have tried.
So you should have, then only you can say, no, V5 is working better for the same data sets compared to V4. Okay.
Yes, sir.
So always have those kind of comparison in your paper or in your thing, right? Whatever you are going to propose.
Okay, sir. We will try that, sir.
Ganesh. Mr. Ganesh.
Yes, ma'am.
This is work done or it's just a review paper?
Yes, ma'am. Work done, ma'am.
Work done. I
Fine.
don't see you're given appropriate results at all. You're just giving a comparative study. There's no clarity of outcome of your work, what you have done.
This was the result finally we have got from that
What do
model.
you want to say out of this? What are your performance metrics?
Yes, ma'am. Accuracy you are saying, right, ma'am?
Nothing you have shown out of this. You should be able to tell what will be generally when we talk of image processing related projects or something, we generally go in talking about the PSNR or SSIM accuracy or other parameters. But here you are not spoken of any of these parameters.
By using YOLO V5 algorithm, ma'am, it's a deep learning algorithm.
Yeah, you're using an algorithm,
yes,
right? But what is the outcome of your algorithm?
It can reduce the manual process, ma'am, for measuring the instruments or anything.
So the same question, how are you validating your results? Do you have any existing
model, ma'am? We have predicted a model and finally accuracy was 89.45%, ma'am.
How did you validate it?
Validated by means of model, ma'am.
Okay, we can move on to the next presentation. We are running out of time.
Thank you.
Okay, maybe the last presentation.
Yes, ma'am.
Detection in soybean crop using YOLO algorithm.
The lecture you are having only 5 minutes of presentation because we have to end the session within 10 minutes. So please fasten your presentation.
Ma'am, my screen is visual. Hello.
Yes, you can go ahead.
Yes, please go ahead.
Yes. So my name is Julius Sadru from Tripoli Airport. My project is weed detection in soybean crop using YOLO algorithm. So these are the content. First one is background, literature review, problem statement, methodology, result, and discussion. After that, conclusion, and finally we have replace this. So background of the project is weeds are a plant which are undesirable, damaging for the crop, and interfere with the growth of other crop plants. So the use of pesticide and herbicide is not effective as it can affect the fertility of soil and other harmful responses are there. So in India, majorly weeds are separated manually by hand. So and as we know, it is time consuming. So we have referred literature review in early weed detection using image processing and machine learning technique, and in Australian chili farm, they have used machine learning. They claimed 94% for the SVM and 63% KNN, and for the 86% for the random forest. In weed detection in raygrass with the deep learning CNN, with this they have got 87% of accuracy for the VGGNet and 91% of accuracy for the RxNet deep learning model. And third one is rice weed detection method on YOLO V4. CNN, and they have got 94% of accuracy score. So our problem description is detection and suppression of wheat manually from the plant is labor cost and time consuming. It may not be accurate also sometimes. So for that, to address the above concern, we propose YOLO based automatic wheat detection approach in this work. So YOLO is the faster object detection algorithm. So coming to the methodology, we have 675 number of weeds and 625 number of crops. Total number is 1300. To localize weeds to localize weeds in a particular plant, we have to localize that. For that, we are using bounding boxes. In generally, bounding boxes is the text file that we give to our model, where we have width of that particular bounding boxes, height, object class, whether it is a crop or weed, and we give coordinate of the center of that particular weeds. So we have raw images. Oh, sorry. We have raw images. We give we annotate that images and we label them. After labeling, we split our data into training and testing part. Generally,
Dileshwar, please put it in slideshow.
Yes, ma'am. Ma'am, now it is okay. Hello.
Continue.
Yes, ma'am. So first, so we have raw images. We annotate that all images. After that, we label them. After that, we train and we split our data into training and testing. In 80% of data we will use for training and 20% data for the testing purpose. So we give 80% data to the model. After getting trained model, we evaluate that particular model and we evaluate that we deploy that model in a real world scenario. So we have experiment setup of i7 CPU and 260 GHz processor with NVIDIA GTX. For our model has a total number of iteration of 4,000 and with starting learning rate of 0.01 with a batch size of 64. So basically in YOLO there is there is a one stage detector and two stage detector. In one stage detector, we have input, backbone, make, and dense prediction. In input, we take images. Darknet work as a backbone of whole YOLO, which will be used for feature extraction. And in neck, pannet is the work as neck for the YOLO, where we have max fully layers and fully connected layers, combination of these layers. And dense prediction and sparse prediction is the output layers, where we are using CNN for the railway activation function and output layer, CNN in output layer. So this is the quantity result for the YOLO V3, V4, and V5. Precision for the YOLO V3, we got 0.49%. Recall, we got 74% with the 72% of FAV and 61% of F1 score. Same for the YOLO V4, we got 51% of precision, 78% of recall, and 76% of MAP with the 62% of F1 score. In YOLO V5, we got maximized, we got 91% of precision, 98% of recall, and 96% of MAP with the 79% of F1 score. So this is the graphical result for the YOLO V5 that we got from our YOLO V5 model. So as you can see, this is the MAP with the processing power. So this is the qualitative result showing the different weights from the plant, and these are the soybean crop, which are showing the class of the crop and probability of the particular crop or the or the class of the particular widths with its probability. So coming to the result and discussion, out of YOLO V3, V4, and V5, YOLO V5 performance is YOLO V5 is outperforms with rather than other, and YOLO V3 mostly held for small size of widths. And in annotation improvement, if we use edge detection technique, so that we could get a better result, because every width cannot have bounding boxes shape. Means every width have its own shape. So we can use we could use edge detection for the particular for the every width. So then we can improve our annotation. And finally, and our YOLO V3 and V4 is sensitive for different width sizes and its classes. So we want to conclude as it is demonstrated that through extensive simulation, result that YOLO can be effective algorithm for the detecting and locating bits. YOLO V5 algorithm is found to be quite faster in training and detecting bits, and YOLO V5 has better accuracy rather than V3 and V5. So these are the some references that I have referred. Thank you.
Mr. Dileshwar,
Yes, ma'am.
can you tell me what is the height of the weed that your algorithm is able to detect?
Sorry.
The height of the weed, the maximum height of the weed.
Ma'am, in according to data set, we have a generally.
The voice is not audible, please.
Ma'am, in general, we have taken picture from plants that doesn't means it is visual view. We can't have any. Sorry. It is visual view only, ma'am. We have not measured.
You are not measured, but you are saying no.
Yes, ma'am. Yes, ma'am. That is created by with other method bounding boxes to locate particular weed, to show that to showing that this is weed or this is crop. For the YOLO algorithm.
So kindly tell me how many types of weed your algorithm is able to detect.
Ma'am, in our data set we have mainly 4 type of weeds.
How many? Sorry, I didn't get it.
5 type of weeds and
5
1
type of weeds.
Yes, ma'am.
Okay. And what is the accuracy rate?
Yes, ma'am. For YOLO V5, I got MAP. In object detection, we used MAP for the accuracy, for the performance matrix, which is 0.96. Sorry, 96%.
Okay. Okay. Thank you.
Thank you, ma'am.
One question from my side. Can I know why are you using the YOLO?
Sir, YOLO is better for the performance wise. It is faster and it has better accurate result. And also it is for the detection purpose. It has like it creates bounding boxes, which locating the particular location of the weed. Also V3 V4 we have used, but the performance is not better than YOLO V5. So YOLO V5 is also faster than V3 and V4.
Okay, this is all.
Thank
you. Any more questions from session chair?
No question from my side.
Okay, sir. Thank you so much.
Thank you.
So Delishia, please stop presenting, and it's a humble request to all the session chairs and all the participants to please switch on their video for a group photo.
Deepthi madam, your voice was not audible. You announced something.
Okay. Ma'am, I'm saying that it's a humble request to all the session chairs and all the participants to please switch on their video for a group photo. Am I audible now, ma'am?
Yes, ma'am.
Yeah, okay.
Yes.
Yes, ma'am. Mr. Anurag? Yes.
Yes.
Mr. Vivek? Thank you all. I have taken the group photo.
Thank you. Can I leave the session?
Yeah. On the behalf of 1 minute, sir. On the behalf of NIT Raipur and organizing committee of the conference, I, Deepthi Sisodia, would like to thank all the session chairs for sparing valuable time as well as providing valuable insight to the authors. It is kindly requested to fill the evaluation sheet so that the best paper award can be decided and finalized. So thank you, sir. Thank you, ma'am. Thank you very much for joining the session. Thank you so much. Thank you, ma'am. Thank you, sir.
Yeah, thank you. So we can leave?
Yes, ma'am. Yes, ma'am. Sure, ma'am.
Deepthi ma'am?
Yes, sir.
Ma'am, transfer host to MISP 2022. Or okay, I'm claiming the host. Thank you, ma'am.
Okay, sir. Thank you, sir. Can I leave, sir?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Running the website. Why is that?